Hello everyone, this is Siddharthan. This is the 12th project video in our machine learning project series. In case you are new to my channel and you want to learn the other projects as well, go to the playlist section in my channel. There you will find a playlist called as machine learning projects. So there you will see the remaining project videos. And if you are new to machine learning, you can also check out my hands-on machine learning course with Python. So it is also available in YouTube. So you will also find that in the playlist section. Okay. So with that being said, let's see how we can build this machine learning system that can predict Big Mart sales. Okay. So first of all, let's try to understand this problem statement better. Let's say that there is a grocery store company or a supermarket company that has several outlets or several stores around the world, and they want us to predict the sales which they can expect. Okay, so you may ask, what is the application of predicting this sales? What can happen by predicting the sales? So there are actually a lot of things that are helpful which we can derive from this predictions. So if we can predict the sales revenue, we can tell the company that what are the challenges they may face, and what are the brands and what are the products that sells the most and other such kind of things. Okay, so this helps the sales team to understand which product to sell and which product to promote and such kind of thing, and they can also make several marketing plans. Let's say that a particular product in particular store is selling the most, and we may find some insights from it as of why this product is selling the most, and this helps the company to make better marketing decisions. So these are some advantages of this particular project. So as we have understood about the problem statement, I would like to explain you one more thing. So this particular project is a regression based machine learning project. So machine learning is generally classified into supervised learning and unsupervised learning. So in supervised learning, we train our machine learning model with labeled dataset. Whereas in unsupervised learning, we train the model with unlabeled dataset. So you may ask, what is meant by these labels and what is meant by unlabeled dataset? So in this particular project, the labels are the target. So to be more precise, I should say that these are targets. So in this case, the targets are the sales amount. Okay, so sales cost or price they are getting. Okay, so that is the target. If we train our machine learning model with those targets as well, we call it a supervised learning. In case we don't use those labels or targets, we call it as unsupervised learning. And this supervised learning can be classified into two types: classification and regression. Okay, and classification, so you can see the definition of both classification and regression. So classification is about predicting a class or discrete values. So we are just predicting some categories. So these categories can be male or female, true or false, and such kind of things. Whereas regression is about predicting a particular value, a continuous value. So this can be predicting the salary of a person given their experience, and predicting a person's age and such kind of things, where this is not category but some numerical value. So this is called as regression, and this particular project is called as regression because we are predicting the sales. Okay, so with that being said, let's try to understand what is the workflow which we are going to follow. Okay, so the first thing is to get the data for this particular project. So for this project, we are going to use Big Mart sales data. So if you are working or learning about machine learning for a while, so you would have come across this Big Mart sales prediction. So this was a very interesting and important project when it comes to machine learning and data science. So we will be discussing what are the different features and variables this data set contains later. So just understand that we are going to use this Big Mart data set. Okay, so once we have this data set, there are a lot of processing to do. So this is like in the previous projects we also had this processing, but the processing work is more in the case of this particular data set. Okay, so there are a lot of processing like encoding the categorical features and other things. So there are some processing things which we need to do in this particular project, and after that we need to analyze the data. So it's called as exploratory data analysis, where we put the data in some suitable plots and graphs and see what are the distribution of various data points and what is the count of various features and such kind of things. So this data analysis helps us to find the meaning the data has to tell. Okay, so this is very important to understand about the data. So once we complete these tasks, we will split our data set into training data and testing data. So what happens is, in machine learning, we train our machine learning model with training data and we test or evaluate it with the test data. Okay, so once we split our original data set into training data and testing data, we will feed this to our machine learning model. In this machine learning project, we are going to use a regression model called as XGBoost Regressor. Okay, so once we train this regressor with training data, we will evaluate it based on the test data. Okay, so this step is called as evaluation. So these are the things which we will be doing in this particular video. Okay, so now let's get into the coding part. So we will be doing our programming in Python. So it will be in Google Collaboratory. So if you are new to Google Collaboratory, or if you are not aware about this Google Collaboratory, just go to my channel, and in the playlist you can find this module called as Python for Machine Learning. In that, the first video will be on how to access this Google Collaboratory and what are the various features in it. Okay, so now let's get started with our programming. So I have uploaded this data set file. So this is the Big Mart sales data, and you can get this data set from Kaggle as well. Just search as Big Mart sales dataset in Kaggle. Okay, so if you search that in Google, so you can find this dataset, this train.csv. So once you download this data, so here there will be a connect option to connect your Google Collaboratory environment. So you can see this files options here. So you need to go here, and you can use this upload to session storage option, or just right click here. So you will find this upload option. So from there you can upload your dataset file. So as you can see here, this is a CSV file, which means comma separated value. Okay, so now let's get started with this. The first step is to import the dependencies. So let me make a text here, importing the dependencies. Okay, so let's run this. So for running a particular cell and go to the next one, you can press shift plus enter. Okay, so first let me import some basic libraries. First, let's import NumPy. So let's import NumPy as NP. So NumPy library is very useful for making NumPy arrays. Okay, and let's import Pandas as PD. So Pandas is useful for creating Pandas data frame. So as you know, we have the data set in a CSV file, right? So it is not easy to analyze the data from a CSV file. So we use Pandas library to get Pandas data frame. So we feed this data set to this data frame, and from there we can do some analysis and processing. Then we need some data visualization libraries. So import matplotlib.pyplot as plt. So this matplotlib.pyplot is useful for making some plots and graphs. So we need one more plotting library. So it is nothing but cbon. So import cbon as SNS. So as you can see, I'm importing the libraries in the short form. So this numpy as np. So pandas SPD. So this is just to abbreviate the libraries. So every time I don't want to use this matplotlib.pyplot, so I just want to use it simply as PLT. Okay, so this is the general convention everyone uses when it comes to these libraries. So that's why we are importing in this small abbreviated forms. Okay, so we have imported numpy, pandas, matplotlib, and cbon, and now let's import some functions from sklearn dot preprocessing import label encoder. Okay, so this sklearn library is one of the very important machine learning libraries. We get several models and pre-processing functions from it. So from there we are importing this label encoder. So I'll be explaining you what is the use of this functions like label encoder and other things. So we need one more function. So from sklearn dot model selection import train test split. So if you remember, I told you that we will split our data into training data and testing data, and this splitting will be made using this train test split function. Okay, so now we need to import our model. So in this we are going to use the machine learning model called as XGBoost Regressor, right? So from XGBoost import XGB regressor. Okay, so this model can also be used for classification. So I have explained you what is meant by this classification, where we will predict the categories, whether it's yes or no, male or female, such kind of things. Okay, so and then we need to import from sklearn import metrics. So this metrics is used to give us some metrics functions that will be used to find the performance of our model. So these are the dependencies which we need. So in this video I will not be explaining how this XGBoost regression model works and such kind of things. So we have a separate module on explaining this, how this model works, what is the math behind this model and such things. So I will be uploading those videos in the future, but in this video it's all about implementing this. Okay, so if you want to know more about this, please wait. So I will definitely be making videos on several models, several important models on machine learning. Okay, so you can also see my machine learning course curriculum file. I'll give the link for it in the description of this video. Okay, so the next step is data collection and processing. So I'll just make a text here, data collection. Okay, so let's put data collection and analysis. So first let's analyze our data before processing it. Data collection and analysis. Okay, so you can see that I have already uploaded this data set here. So I'll give the link for this data set in the description of this video. You can download it from here. So here just go to this options menu. There you can find this copy path option. So just copy the path. So now we are going to load the data from CSV file to a pandas data frame. Okay, so let me make a text here as loading the data set from CSV file to a pandas data frame. Okay, so now let me create a name for this particular data. So let me name this as Big Mart data. So Big Mart is very famous supermarket networks. So they provided this data, and it is a very famous data set in machine learning. Okay, so Big Mart data, which is equal to pd dot read csv, and inside the quotes let's paste the path of this data set file. So we have copied the path earlier from here, so I have pasted the path here. So this pd represents pandas, as you can see here. So this read csv function will load the csv file in a pandas data frame. Okay, so pandas data frame is nothing but a more structured table. Okay, so let's print the first 5 rows of this data frame. So first 5 rows of the data frame. Okay, so mention the data frame name, which is Big Mart data. Okay, dot yet. So this yet function will print the first 5 rows of the data frame. Okay, 1 second. Okay, so as you can see here, these are the rows. So let's understand what are these rows. So first we have this serial number. So and then the second column. So this actually is the first column. So let's not include the serial number. So the first column is on item identifier. So these are identification number for a product. Okay, so there are several products and each product has an identification number. Okay, so there will be 3 codes here. So here is this FD, right? So FDA, this FD represents food, so something eatable. So this DR represents some drinks. So and it's the same here, FD and FD, and NC means non-consumable. So you can just come to this item type. So we have this item identifier, item number for each of the products, and we have this item type. So you can see here, as I told you, FD means food item, so it is some dairy products, and the DR represents drinks. So we have this soft drinks type here, and this is also again food type, which is meat, and we have again some foods, and NC means non-consumable. So non-consumables we have household. Like this we have several types of products and several item identifiers, specific identification for each of the product. Okay, so this is the first column. The next column is item weight. What is the weight of that particular project in kilograms? Okay, so that is given in this item weight column. And then we have the item fat content. So what is the fat content of this particular product? Okay, so we have this low fat level, regular fat level, and such kind of things is present in this item fat content. And this is item visibility. So what is the visibility of that project in a particular supermarket? Okay, in a particular store. So how much it is visible and how much people are buying this particular project. So each of this row represents one product. So this FTA represents some kind of dairy product, and this DR represents some kind of soft drinks, and this represents another food material, which is kind of a meat. Okay, so this is given in the item type, and we have the MRP price here. Okay, so it is, these are in US dollars. Okay, so these are given in item MRP, which is the maximum retail price. Then we have the outlet identifier. So similar to this product ID, we have this outlet identifier. So outlet represents different stores. Okay, so this Big Mart has several stores, and we got a set of stores here. Okay, so these are identification number for such stores or such outlets. Okay, so these are that identification numbers, and we have the year on which it is established. Okay, so these are the years. So 1999, this particular outlet 049 is established, and such kind of things. So we have various establishment years, and we have the outlet size. Okay, so we have a medium outlet size and a high outlet size, and we have this NAN value. So NAN means this particular value is missing. So in this video we'll also be explaining you how we can handle this missing values. Okay, so it comes under data pre-processing. And then we have this outlet location type. So tier 1, tier 2, tier 3, whether it is present in a very populated region, or it is present in a less famous region, such kind of things. So tier 1, tier 2, and tier 3, such kind of outlet location type. And then we have this outlet type, whether it is a supermarket or otherwise it is a small grocery store. Okay, so such kind of outlet types, what is the type of that particular store. And finally we have this item outlet sales. So what is the particular sales value of that particular product. So if this is the FDA 15, so this product, and this is the sales of that particular product in that particular outlet. Okay, so similarly we have the outlet sales value. So so what it represents is, in this particular outlet, what is the sales of this particular product. So that is given in this item outlet sales. So this is what we are going to predict here. So this is our target variable, and all these other things are called as feature variables. Okay, so as I have told you earlier, in this we are using the target variable also for our machine learning model. So hence it is a supervised machine learning project. Okay, so this is our target variable which we are going to predict. So I hope you have understand what are the different features that are present in this data set. So now we need to understand more about this data set, and do some processing on the data set before feeding to our machine learning model. So what are these processing? You can see here these are in the form of text and numerical values, right? So and then we have this as numerical values, low, fat, regular, and such kind of things. So we cannot feed this string data. So string means text or some words. Okay, so we cannot feed this text data to our machine learning model. So we need to do some processing on this data. So these are categorical data. So I'll also explain you what is meant by categorical data later in this video. So we need to convert this text to suitable numbers. So I will be explaining you how we can encode these text data into numerical data as well. Okay, so now what we will do is, let's try to understand more about this data set. So now I'm going to see the number of data points and number of features. Okay, so here the data points represents the number of different products we have, so or the number of rows we have in this data set, and feature represents all these columns are features. Okay, so basically we are going to find the number of rows and columns in this data set, and data points represent rows and number of feature represents column. Okay, so mention the data frame name Big Mart data dot shape. So this will give us the number of rows and columns. Okay, so totally we have about 8523 values. So 523 rows, or 8523 different products, and we have 12 features. So these columns are the features. So the first column is item identifier, item weight, and all the way through item outlet sales. So totally we have 12 features. Okay, or 12 columns. So this is a pretty good size of data set, but this is not very large. In machine learning we also deal with data set which is several thousand data points large, or even lakhs or hundreds of thousand. Okay, so this is a pretty good size of a data set. So it is almost near to 10,000. So it is a good size. Okay, so now let's get some information about this data set. Getting some information about the data set. So we are going to see what are the data types in all these different columns about the data set. So again mention the data frame name Big Mart data dot info. Okay, so this info function will give us some important informations. So totally we have 8523 values and 12 columns. So here you can see non-null count. So null values means missing values. So you can see here in this outlet size, in the first 5 rows we have one missing values, this NaN. Okay, so NaN means not a number, or it basically means it is a missing value. So non-null values means those values are not missing, or the values that are present in the data set. So out of 8523, all the values are present here, whereas in the item weight column some values are missing. Okay, and you can also see in this outlet size column we also miss about 2000 data points. Okay, so this gives us the number of values present in the data set. And what is the data type here? So you can see the data type as object, float, again object, and we have this int. Okay, so int and float represents numerical values, right? So here the item weight is float, it is a numerical value, and if you come to this establishment here, it is an integer value. Okay, so 64 represents 64-bit integer and float. And object, so we have this object, so you can see which columns are objects. So item identifier is object, so item identifier is, as you can see, so is an object. And then we have this item fat content, so it is also an object. Okay, so the values which are not numerical, so these are textual values. And to be more precise, we call these as categorical values, because so this item fat content contains two categories, low fat and regular. So these are two categories, right? So these are two classes. And if you come to item type, this is also categories, whether it is a dairy or soft drinks or meat, such kind of categories. And it is similar to this outlet identifier and outlet size, whether it is medium, high or small. So we don't have any numerical and discrete values, so we have some classes, right? And the same with tier 1, tier 2 and outlet type. So these are categorical values. So other than these numerical values, the others are categorical values. So I'll just make a text here and represent what are the categorical values we have, categorical features. I'll make a text here, categorical features. Okay, so let me make a list of things. So item identifier, so it is an object type. So as we know, it is a categories of different products, right? So I just put it here. And the second one is, so the item weight is an integer, so it is not categories. And the item fat content is, of course, it is category. It tells whether it has high fat content, low fat content, or regular fat content. So it is a categorical value. The third categorical value is visibility. So visibility is also given in some metric, in some numerical value. So the next is item type. Okay, so let's just mention this also. So item type, so whether it is a meat or soft drink or something. Okay, so it is also a categorical value. And the next categorical value is outlet identifier. So it is also a categorical value because it is some identification value. So let's copy this outlet identifier. Okay, so we don't need to put this establishment here in the category, so let it be the numerical values. And the outlet size, so outlet size is also categories because it tells whether it is medium, high or small. Okay, so outlet size. So let's copy this. Okay, so the next one, so outlet location type, whether it is a tier 2 or tier 1, such kind of thing. So it is also category. So, okay, so let us put it here. And the next one is outlet type. Okay, so this is also categories because it tells whether it is a supermarket or it is a grocery store, such kind of things. Okay, so let us put this here. Okay, so these are the different categorical features we have. So totally we have about 7 categorical features. So out of 12, 7 are categorical features and the remaining 5 are numerical features. Okay, so now we can do some more analysis and processing on these categorical features before we can feed this to our machine learning model. So now what I'm going to do is check for any missing values. Okay, so checking for missing values. So you cannot feed a data set which has a missing value to machine learning model. So we also have a separate video on this handling missing values. So it will be given in the 4th module of our course called as data collection and pre-processing. Okay, so everything is given in the playlist. So it will be in, so if you cannot find that video, just comment in the video. I'll just give you the link for that particular video. Okay, so now we are checking for missing values. So mention the data frame Big Mart data dot is null. Okay, dot is null dot sum. So this will tell us the number of missing values we have in each column. So as you can see, we have totally 1463 missing values in the item weight column, and we have about 2410 missing values in the outlet size column. Okay, so the amount of data that is missing is pretty large in this particular data frame, so we need to do some processing with it. Okay, so now let's see how we can handle this, missing values. Okay, so here we can also note that this item weight is a numerical column, whereas this outlet size, it tells whether it is medium, small or large. So this is a categorical column. Okay, so let's see how we can handle this missing values. Handling missing values. Okay, so here we are going to be needing two metric. So one is mean. So we all know that mean represents the average value, right? So mean represents average value, and we need another parameter called as mode. So mode means most repeated value. So let's say that there are a set of numbers, and mean is what is the average of those set of numbers. So this is called as mean, and we will find the mean of this item weight column, and we will convert all these missing values to that particular mean. So it will be a good method to replace this missing value. So this method is called as imputation. So we are going to impute the missing values in this item weight column using the mean value of this column. Okay, and the second one is mode. As you can see here, outlet size. So this outlet size will be in either it is medium, small or large. So we cannot find the mean value of text data for a categorical data. So in this case we are going to use mode. So what is meant by mode? So mode is, let's say that list contains this small, large and high. So these three values in a repeated fashion. Okay, mode is nothing but which particular class or which particular text is repeated the most. So this is called as mode. So mean is the average value and mode is the most repeated value, and we will convert the missing values in this item weight with the mean of this particular column, and in this outlet size we will find the mode of this outlet size, and we will convert all the missing values to its mode. Okay, so the important thing to note here is we will be converting the missing values in the numerical column using the mean, and converting the missing values in the categorical feature using the mode of that particular column. Okay, so we cannot find, we cannot replace this missing value with mean of other columns. So we just need to find the mean of this particular column and replace it. So that is one important thing to note. Okay, so now let's see what is the mean value of this item weight column. So mean value of item weight column. Item weight column. Okay, so Big Mart data, let's mention the column name. So here you can see the column names if you put this quotes inside this square bracket. So you can also go to your data frame and see the column name. So, okay, so here we are going to change the item weight, right? So you can give this item weight here. Now just put a dot and mean. So this will give us the mean of this particular column. So press shift plus enter to run this cell and go to the next one. So the mean value is 12.857. So this is the average or mean value of the product weight. Okay, so now let's see how we can fill the missing values in this particular column with mean. So filling the missing values in item weight column with mean value. Okay, so Big Mart data, again mention the column name, item weight, dot fill NA. Okay, so fill NA means, so it will fill all the missing values. So NA represents not available. So not available means missing values. Again mention the column name. So how we are going to fill this? By taking the mean, right? So Big Mart data, item weight, and dot mean in place is equal to true. Okay, so let's see what we are doing in this particular line of code. So we are taking this item weight column. In this item weight column, I am going to fill all the missing values by the mean of this item weight column present in this Big Mart data. Okay, so basically we are just taking this item weight column, replacing all the missing values with the mean. Okay, so in place is equal to true means I want to replace all the missing values. So in the place of these missing values, I want to replace it with mean. So that is why we are giving this in place. So if you don't mention this in place, if you run this code without this in place, so it will give you the replaced values only in this particular set. It won't be stored in your original data set. So if you give this in place is equal to true, it will be, this missing values will be replaced in your original data set. Okay, so now let's run this. Okay, so now you can just copy this and paste it here and see whether the missing values is still there for item weight column. Okay, so now you can see here we have the missing values only for this outlet size column. That means we have replaced successfully all the missing values in this item weight column. So now we are going to see how we can replace the missing values in outlet size with mode. Okay, so I'll make a text here as um, replacing the missing values in outlet size column. So this is, kind of different from what we have did in this, in item weight column. So there are some different procedures which we need to follow. So replacing the missing values in outlet size with mode. Okay, so we need to do some processing here. So I'll create a variable as mode of outlet size. Okay, so mode of outlet size is equal to mention the data frame Big Mart data dot pivot table. Okay, so I'll explain you in a minute what is meant by this function. So you can also see this description of this particular function. So this pivot table, so it creates a spreadsheet style pivot table as a data frame. The levels in the pivot table will be stored in multi-index object. So if I run this, you can understand. So we are just getting some kind of a table where we want particular columns. Okay, so inside this we need to give some parameters. So you can see the parameters here. So first one is values, right? So values is equal to outlet size. So I want to take all the values from this outlet size column and mention this column. So we need another parameter. So this column. So you can see what is meant by this. If an array is passed, it must be the same length as the data. Okay. So key to group and pivot table. So if array is passed, being used as the same manner. Okay. So let's use this. Here the column is okay. So columns is equal to outlet type. So I'll explain you why we are using this outlet type column along with this outlet size. So if you remember, there are no missing values in this outlet type. We have missing values only in this outlet size, right? So let's understand why we are using this. And we need another function, this AGG function. Okay. So in this, we are going to use a function in this particular parameter. So AGG func. Okay. And here we are going to use a lambda function. Lambda and x is to x dot mode 0. Okay, so let's run this. Now I'll explain you why what we are doing in particular case. Okay, so outlet size, so it should be in caps. Yes, because it's given in caps in our data frame. Okay, so now I'm going to print this mode of outlet size. I'll just copy this. Print. Okay. So this is the pivot table. So what we are doing is we are taking two columns, outlet size and outlet type, because these two columns are correlated. Okay. So if you take this, we have this outlet type column here. So there are 1, 2, 3, and 4 different outlet types. So the first type of outlet is grocery store. The second one is supermarket one. Which is supermarket type one is the second one, supermarket type 2, and supermarket type 3. So these are the 4 different outlet types, and you can see the outlet size. So this is the mode value of grocery store. So mode means, as I have told you, it is the more number of repeated values. So if the outlet type is grocery, in most of the cases the outlet size is small. As we know, the grocery store is almost small when compared to a supermarket, right? So most of the grocery store are small, and most of the supermarket type 1 are small, and for supermarket type 2 the outlet size is medium, and for type 3 it is also medium. Okay, so this is the mode for each of these different outlet type. Okay, so we cannot take the mode of this entire column, so it won't be a correct method. So what we are doing is we are comparing this with outlet type. So if it is a grocery store, then the mode's repeated value is small, so this becomes its mode. And for type 1 it is small, and type 2 medium. So what we are going to do is take these 240 missing values. Okay, and in that missing values we will be taking the the outlet type. So let's say that this particular this is missing, right? So in this fourth row, so this ftx07, we have a missing values in outlet size. So what happens is, so it will see what is the outlet type. So it is a grocery store, so it will change it to the mode which is small. Okay, so likewise it takes all the missing values, and it will compare it with the outlet type, and it will replace the outlet size depending on this outlet type. So that is what we are doing. Okay, so now I'll create another variable as missing values. So missing values, because we need to take that value separately and replace them. So missing values is equal to Big Mart data, mention outlet size, and is null. So I'm taking all the null values or missing values. So what happens is this will give us a list or array of true or false values. So you can just print this and see. So print missing values. Okay, so you can see it gives a list of true or false. So it is checking whether it is null. So false means it is not null. That means the value is present. So what happens is true represents a particular value is missing. So you can just see this. I'm checking whether a value is missing, whether it is null, false. That means the value is present. So whether the value is null, true. That means the value is missing. So we get an array of true or false, where false represent the value is present and true represents the value is absent. So now we are going to take all these true and convert them to the mode of the respective outlet type. So that is what we are going to do. And for this, let's do some work. So now we need to understand what we are doing in this particular function, right? Okay, so we take this pivot table. So we are just creating this spreadsheet like table. So in order to compare what is the mode of their respective outlet type based on this size. Okay, so the values we are taking is outlet size, column which we are comparing is outlet type, and argument, so this arg function. So we are using this lambda function. So what is meant by this lambda? So we all are familiar with functions, right? So we use this def. So if we want to create a function in Python, we use this def. So this is a keyword, right? So if you mention this def and let's mention some, let's say that label. So this will create a function called as label, right? So in this particular function, we can write some few lines of code, and we can use that particular function again and again in our code. What if in case we need just use that function in only one situation? So we don't want to use a particular function in several cases. So in that case, we use lambda over define. So define means you will just mention that function in one place, and you can use that function multiple times. So here I don't want to use this function multiple times. I just want to use this function only one time. So in this case, we can use this lambda. So the functioning of this lambda is very similar to define function in Python. So they both are function, but it can do only one function. So what we are doing is we are taking this x. So x represents this particular outlet size column, and it is taking the mode of that particular column. Okay, so we are just taking the mode for this outlet size and outlet type. So that's why we have mentioned the 0 to represent the index. So we are taking this x and finding the mode of this column. Okay, and we are just using it to print it here. Now let's see how we can use this lambda function again to convert this missing values to a mode value. So we need to again create a separate lambda function. So this lambda function is just to give this mode. Now we will create another line of code to replace the missing value with the mode. Okay, so Big Mart data dot loc. So loc means locate. So it's going to locate some values. What values we are going to locate is this missing values. Okay, so I just copy this and put it here. Okay, so I'm going to locate this missing values. So you check for which values are true and false. And where I'm going to find the missing values is in the outlet size column, right? The outlet size, and which is equal to Big Mart data dot locate, again the missing values, comma outlet type dot apply lambda. So again we are creating a lambda function, and this time to replace the values. X is to mode of outlet size. Okay, so what we are doing is, so I'm taking this Big Mart data, so I'm locating particular values. So which values I'm locating is this missing values. So all these true and false will be taken. So this missing values will be taken for this particular column. So I won't disturb any other columns. So we have totally 12 columns. I just want this outlet size column, and in that size column I'm going to convert some things. So what I'm doing is, again I'm taking this locate. So I'm just locating some values in this missing value. So what I'm locating is outlet type, and I'm applying a function. So what I'm doing is, this X represents this outlet size and outlet type. So I'm taking the mode of outlets. So this is very similar to this particular case. So we are taking these four outlet type: grocery store, type 1, type 2, type 3. So and we are converting all the outlet size to whether if it is a grocery store, it will be converted to small. For this type 1 it is small, type 2 it is medium, and such kind of things. Okay, so this is what we are doing this in this lambda function. So we will take this outlet size and outlet type, and for missing values we will convert the missing values based on this outlet type. Okay, so let's run this. So this will replace all the missing values with mode of the corresponding outlet type. So again you can check the number of missing values. So I just copy this. Let's see whether the missing values is filled or not. Okay, now you can see here we don't have any missing values in any column. So this is how you can handle missing values in a numerical column and in a categorical column. Okay, so the next step is to do some analysis on the data. Okay, so let's make a text as data analysis. So now we are going to put this data in some graph and see what is the distribution of the data and other some insights that we can get from this data. So this part is about data analysis. So Big Mart data, so dot describe. Let me explain you what is the use of this particular describe function. So this describe function will give us some statistical measures about the data. Okay, so let's run this. Okay, so it gives some statistical measure only for those numerical values. So first is the count. Count means the number of values we have for all the numerical columns. So these are the numerical columns, right? So what is the count? So 8523. So totally we have 8523 data points, and we have these many item weight values. And what is the mean of these item weights? Okay, so the mean is 12.85. So most of okay, so this is the average of all the item weight column, and we have the standard deviation. So what is the standard deviation for each of this column? So each have their own mean and their standard deviation. So second is the item visibility, item MRP, etc. And then we have the minimum value. So what is the minimum item weight value, what is the minimum visibility value, and such kind of things. And then we have the 25th percentile, 50th percentile, and 75th percentile maximum value. So what is the maximum value in this item weight? And percentile, so these are not percentage. So percentile means, so if it is 25 percentile, that means 25 percentage of values are less than 9.31. 50th percentile is 12.85. So that means 50 percentage of the values are less than 12.85. So that is meant by this percentile. Okay, so now let's take this numerical features and do some plots. Numerical features. So I'm using this SNS.set. So if you remember, we have imported this Cborn library as SNS. So this SNS dot set function will give us some theme for our plots. So it will give some grids and other things. So that is the use of this SNS dot set. So if you run this one time, it will be followed in all the plots you make. So first I'm going to create a plot for item weight column. So item weight is the first numerical column we have. So item weight distribution. So what is the how the value is distributed in this particular column? So that's what we are going to understand. So for that, I'm going to use this plt dot figure. So plt dot figure. So plt means matplotlib.pyplot. So we have imported it in the short form as plt. So we are using that particular library. So plt dot figure. So in this mention the figure size. The figure size is equal to 6 comma 6. So you can change. This is just to the size of the plot we want. So this is the x-axis size and this is the y-axis size. Okay, so figure size, and then I'm going to use a distribution plot. So this distribution plot function is present in cbound. So sns dot dist plot. Okay, so dist plot means distribution. So mention Big Mart data. So I'm going to make a distribution plot in this particular data set for item weight column, right? So item weight. Okay, now let's also give a title for our plot. Okay, so the title is not necessary. Let's just show the plot. So plt.show. So this plt.show will print our graph, print our plot. Okay, let's run this. There is some error. Okay, so we need another parenthesis here. The figure size is equal to, this should be enclosed in another parenthesis. Okay, so one closing parenthesis. Okay, so got fig size. So got an unexpected argument called as fig size. Okay, so we need to remove this underscore. So this is how our item weight column is distributed. So we have the item weight from 5 kilogram to 20 kilogram, and we have maximum values in this 12. Okay, so there are a lot of values in this 12, and this is the reason we get the mean values 12.85 something. Okay, so a lot of values are distributed in this particular weight. Okay, so these are the insights which are very important for us. Okay, so this tells us what is the average weight when compared to the other products we have. So in this total products, so this total 8523 products, the average weight is about 12.8. Okay, so now let's also find the distribution of other columns as well. The second numerical column is item visibility, right? So item visibility, so I'll just copy everything here and let's just change the names. So this is for item, we can copy it from here. Item visibility, just put it here and also here. So it will give us the distribution for this item visibility column. Okay, now as you can see here, there is a skewness. Skewness means there is value distributed more in one side of the graph. So these are the distribution. So the item visibility values and more as a value around 0.05, and less values have values more than 0.15. Okay, so this is about item visibility column. And next let's find the distribution of the third one, which is item MRP. Okay, again I'll copy this. So it is already, yeah, okay. So let's put it here, and now we need to change this item weight to item MRP. Item MRP. Okay, so let's run this. Okay, so as you can see here, a few values are, so it is not a normal distribution. So there is peaks in some kind of in some products. So there are a good amount of products around this 50 rupees or $50 price, and also in this $100 and $200. After this, the products is kind of less. So we have more products in this range of 100 and 200. So 100 and this 170 mark. Okay, so this is how the price value is distributed in our data set. Okay, so you may ask why we are doing this. So this tells us important insights. So if you are working on some data science projects, these insights are very important because they tell us what how our data is distributed and how the values are in a range. Okay, so next we have this item establishment here and outlet establishment, the particular outlet establishment here, and item outlet sales. So I just copy this outlet sales, item outlet sales. So first let's just put this here. So, and I'll copy this. So we are going to see the distribution of sales. Okay, so This is also a kind of skewed, or it is also more in but one side of the curve, and it is not a normal distribution. So more sales are in the range of about 2000, so 10,000 to 2000. Okay, so this is how you can understand the distribution of numerical values. And finally we have this outlet establishment here, right? So here we are going to use a count plot instead of a distribution plot, because count plot gives us a better meaning for this particular feature. So outlet establishment here, let's copy that. Outlet establishment here column. Okay, so plt dot figure, and figure size, so let's put the figure size as again 6,6. Okay, so now we don't want a distribution plot, we want a count plot. So SNS dot count plot, and in that mention x. So here the x is nothing but the column name. So mention the column name, which is establishment here, and we also need to mention the data. And here the data is nothing but Big Mart data. Okay, so Big Mart data plt dot show. Okay, so we have the outlet establishment here. So we have the year 1985, 1987, 97, all the way to 2009. So these are the years on which different outlets or different stores are established, and we have a lot of values, a lot of stores are established in the year 1400. Okay, so a lot of products are basically created in this particular year, and the distribution is kind of similar for all the years, but it is kind of less only in this 1998. So this tells us how many products are sold in what years. Okay, so that is what we are getting it here. So that means more number of outlets or more number of products are sold and created in this particular 1985, and it is very less in 1998, and all the other years are almost same. Okay, so this is what we are getting in this. So these are distribution, but these represents the actual numbers. So in this 8,000 data sets. So we have this 8,000 data sets, right? So in this, the most of the data points, about more than 1,000, are in created in this year 1980. What is the year? It's 1985. So others are almost similar, the density of these particular values. Okay, so these are the numerical values, and next we need to check the similar things for categorical features. Okay. So in this categorical features, we know that totally we have 7 categorical features, right? In this, we are going to exclude this item identifier, and so we'll be excluding this item identifier and outlet identifier, because they are just identification numbers. So we don't want to put that in some plots, but we will find the plot for the remaining columns. Okay. So we are just going to use the same count plot as we have used for this establishment here. Okay. So I'll just copy everything here. Let it let us put this here, and just we need to change the column name. So the first categorical column, we have this item item, so we are not going to include this. So it's item fat content. Okay, let's see what are the different features this item fat content has. Let's run this. So we have columns as low fat, regular fat content, again low fat content, LF, and regular. So the important thing to note here is we need to clean this particular column, because this low fat and this LF all represent the similar thing, right? So we need to put this low fat data and this LF data to this particular low fat data, and regular also represents regular. So we need to put this data in this. So this means this data is not clean, and we need to process this data. So we will be dealing with this in a later point of time after we analyze this data. Okay, so this is one thing that we have we got interested in while we found the analysis. Okay, so we are going to put both of these columns in this particular label, and the regular to regular. Okay, so the second categorical column, so again I'll just copy this, and the second categorical column is item visibility is a numerical column, item type. Okay, so let's put it here. Okay, so it is very congested, so we need to increase the size of this x-axis. So this is the x-axis size. The first number is the x-axis size and the second number is the y-axis size. So 30 will be a good number for this particular plot. So now that it is in a spacious manner. So these are the different uh, items or food types we have. Okay, so the item type, so it is dairy, soft drinks, meat, fruits and vegetables, household, baking goods, snack foods, frozen foods, breakfast, etc. Totally we have about in this case it's around 16 values. Okay, so 16 item type values are here, and we have more values in this fruits and vegetable columns and snack foods column. Okay, so this is the distribution of this item type. Okay, so the next column which we need to plot is the outlet size column, right? So I'll just copy this. So we just need to change this item type to outlet size. Okay, so I'll just copy this again and put it in the 6. Okay, so we don't want this title, or let this title be. Okay, so let's run this. Okay, so I'll just change this size to 6,6. Okay, so we have three outlet size here. So one is medium, small, and high. Okay, so these are the outlet size. So similarly, you can find the plots for the other categorical columns. So the other categorical columns are outlet location type and outlet type. Okay, so this is it is the similar procedures. You just need to change the column name. Okay, so okay, 1 second. Okay, so the next thing which we need to do is data pre-processing. Okay, so we are done with the data analysis part where we have plotted this numerical values and categorical values. So the next step is data pre-processing. So I'll just make a text here as data pre-processing. So let's again print the first 5 rows of the data frame. So Big Mart data dot 8. Okay, so in this case what we are going to do is convert all these categorical columns or categorical columns into numerical values. So as I've already told you, we cannot feed this text data or string data directly to our machine learning model. So we need to encode all this data to suitable numerical values. And for this, we are going to use a method called as label encoding. Okay. So now what I'll do is, so there is another thing which we need to discuss here. So I have told you previously that we need to change this low fat and LF to this low fat, right, and regular to this particular regular. So let's do that thing before encoding it. So Big Mart data and item fat content, item fat content. So in this we need to see what are the different values we have. So value counts, this will tell us all the unique values. So we have low fat, regular, LF, reg, and low fat. So we need to change these three, right? So let's do that now. So Big Mart data dot replace, and we need to mention this curly brackets here. So I'm taking item fat content column. So item, let's copy this, item fat content, and in this I want to replace few things. They are, if the value is low fat, I want to encode it to low fat like this. Okay, and if it is LF, I want to change this to again low fat. Okay, and the final thing is to change this reg. So it should be in quotes. So reg to regular. Okay, so it should be changed to this regular. Okay, okay, so these three things we want, and finally we need to mention this in place. So this will change, this will replace all those values, and it will edit it in the original data frame. So we need to mention this in place. So in place is equal to true. So we are just taking this Big Mart data, and in the item fat content, we are changing low fat into this kind of low fat. So both are in caps. So this LF also to low fat and reg to regular. So let's run this. Okay, so invalid syntax. So okay, so I think I have missed some codes here. Hmm, regular. Okay, so it shouldn't be equal to sign. So that's the error here. So let's run this. Okay, so we can again check this value counts whether it, so to see whether it has worked well. Let's run this. Okay, so now you can see here we have only two categories here. One is low fat and the other one is regular. So we don't have these three other columns. Okay, so now let's do this label encoding. Okay, so I'll just make a text here, label encoding. So in this, what we are going to do is take all the string values. So we are going to take all the categorical values. So the here we have this categorical values as, yeah, so these are the 7 categorical values, and we are going to take all these categorical value and transform them to some numerical values. Okay, so just come here and let's do the label encoding part. So encoder, so we have imported this label encoder function from sklearn.preprocessing, right? So let's put that here, label encoder. Okay, so let's run this. And now we have the Big Mart data. Mention the column name. So the first column is this item identifier, right? So item identifier, Big Mart data, item identifier. So this is the first categorical column. This is equal to, so we need to mention this encoder. So this encoder is nothing but label encoder function. So encoder dot fit transform. So this will transform all the numerical values into corresponding labels. So fit transform Big Mart data and item identifier. So again we need this item identifier here. Okay, so when you run this, what happens is it will take all the values in this identifier and it will give one label to each of the unique values. Let's say we have this low fat and regular, right? So this low fat will be changed to 0 and this regular will be transformed to 1. So these are called as labels. So this is how you can convert categories into numerical values. Okay, so it's I'll check whether this is correct. So Big Mart data item identifier, which is equal to encoder.fit transform. Okay, so now what we are going to do is do the same for all the other categorical columns, so all the other 7 categorical columns. Okay, so I'll just copy this. So this is for the second column, this is for third, fourth, fifth, sixth, and finally 7. So totally we have 7 columns, right? So the second one is for this item fat content, so which has low fat and regular. So you need to change it here and here. Okay, and the third column is item type. So I'll copy this. So it's the third column, so item type, and the fourth one is outlet identifier. So let's copy this and next one is outlet size, and outlet location type. Okay, sorry, I again copied it. Outlet location type, and finally it's outlet type. Okay, so this will encode all the categorical columns into corresponding numerical values. Okay, so let's run this. Okay, so now you can again print the first 5 rows of the data frame. Now let's see whether these categorical columns are there or not. Okay, so now you can see here we only have numerical values here. So these categories are given some specific numerical values if it is unique. So this is how you can encode all the categorical columns into numerical values, and this is the important data pre-processing step. So the remaining steps are very simple. So now what we are going to do is we are going to split our data and features. So I'll just make text here. So splitting, sorry, not data and features, it's splitting features and targets. Features and target. So as you know, here the target is outlet cell, right? So this last column, item outlet cell, so that is the target. The remaining columns are features. So let's take two variables x and y, and let's store all the features in x and all the target in y. Okay, so Big Mart data. So now what I'm going to do is drop the target column. Okay, so dot drop columns is equal to item outlet sales. So this is the column I want to drop, and let's put axis is equal to 1. So if you are removing a column, you need to mention axis is equal to 1, and if you are removing a row, we need to mention the axis is equal to 0. Okay, so what I'm doing is I'm removing this outlet item outlet cell, the target, from this data frame, and storing it in x, and this particular item outlet will be stored in this y. Okay, so Big Mart data item outlet set. So this will give us x and y, where x is the feature and y is the target. So we can print x and y separately. Now you can see it doesn't have this item outlet cell, whereas if you print y, it contains this entire last column. Okay, so this column will be stored in y. Okay, so this is how you can split your features and target. So the next step is to split our data into training data and testing data. Okay, so splitting the data into training data and testing data. Okay, so we need to create four arrays: x train, x test, y train, and y test. Okay, so we need to use the train test split function. So if you remember, we have imported this train test split function from sklearn.model selection. So x and y test size is equal to 0.2. So 0.2 means I'm taking 20% of the data tested. So I'll explain you in a minute what we are doing in this line of code. And I'm taking this random state. Random state is equal to 2. Okay, so let's run this. So what we are doing is we are splitting the data into training data and testing data. So we are just taking this x and y. So this x will be splitted into training data and testing data, and the corresponding y for the training data will be stored in y train. Okay, so you can see this x train, right? So x train is the training data. So this x is splitted, and the corresponding y value, this corresponding outlet sales value, will be stored in y train. And we have this testing data here, and the corresponding this y value will be stored in y test. So basically we are splitting this x and y into these two kinds of data, and that's why we are mentioning this x and y here. Test size means the size of our testing data. Generally we take 10 to 20% of the data as testing data, and random state is equal to 2. So random state means if you mention random state is equal to 3, your data will be split in a different manner. If I use 2, it will be in a different manner. If you want to split your data in the same manner that I am splitting, you need to mention this 2. Okay, so this is like an identification number for similar splitting. Okay, so now we can just run this. So we have already run this, right? Okay, so now let's print the original data set shape, x dot shape, comma x train dot shape, and x test dot shape. Okay, so let's run this. It will give us the number of data points we have for training data. So this is the original data set, which is X. It is 8523, and for training data we have 6818 data points, and for testing data this is 20% of this data. It is just 1705. Okay, so the next step is training our machine learning model. So we have successfully splitted our data set. Then we just have two more steps to do. One is training our machine learning model and evaluating it. So machine learning model training. Okay, so the next, let me name the model. So we are just using a XGBoost regressor, right? So XGBoost regressor. So if you remember, we have imported the XGBoost regressor function from this. So go to this importing dependency. So you can see this XGBoost, right? So from there we have imported this XGB regressor. So I'll just copy this and let me create a variable as regressor is equal to XGB regressor. Let's put a parenthesis. So let's run this. So this will load this regressor model to this regressor variable. Okay, so XGB regressor to this regressor variable, and now we are going to fit this data. The regressor dot fit. So this is what is called as training our machine learning model. So in the fit, we need to mention the training data. So as I've told you, we will be training our machine learning model with this training data, and we will be testing it with testing data, right? Evaluating with the testing data. So here the training data are X train and the corresponding price value is in Y train. So we need to mention it here. Okay, so this is just like plotting. So X train and Y train. Okay, so what happens is now the model tries to find the pattern between X and Y. So here X is the feature, Y is the target. So it will find the pattern between them. So what is the relationship between them? So if it is a particular item and if it has a particular weight and it is in a particular store, the value can be the price value can be in this range. And similarly, it will find this for all the data, and that is what is happening in this regressor.fit function. Okay, so when we run this, our model get trained. Okay, so now this regression model is trained and we can use this model to make our prediction. Okay, so the next step is evaluating it. So this is the last step which is evaluation. So first I'm going to predict this on training data as well. So okay, so prediction on training data. So training data prediction is equal to regressor. So as we know that we have trained our regressor model, so mention this regressor dot predict. So this will predict the y value if you give the x value. Now I'm going to give this x train. So what I'm doing is, if you see here, we have trained our model with x train and y train, right? So now what I'm going to do is, I'm going to use this trained model to predict some values. So I'm giving this y train alone. So it will try to predict the y values, and I'm storing this predicted value in this variable called as training data prediction. So this y train is the original y value and training data prediction is the values predicted by our model. Okay, so let's run this, and now let's find the r squared value. So r squared value. So r squared value is very useful for checking the performance of our model. So this r squared value lies in the range of 0 to 1. Okay, so that is the range of this particular value. Let's put this as r2 train. So if you remember, we have imported sklearn from sklearn. We have imported this metrics library, right? So this metrics library has this r2 score function. So r2 train is equal to metrics dot r2 score, and we need to mention the original values. So the original values are y train, and the values predicted by our model is training data prediction, right? So it will try to find the distance between them. So what it basically is, so it sees whether how close the value is predicted by the model and how close is the original value. So y train is the original value and this is the one predicted by our model. So it tries to find the distance between them. Okay, so let's try to print it. So generally we say that if the R2 score value is R squared value is if it is close to 1, then it is a good model, maybe more than 7.75 or something, but it is not always the case. So this R goodness of this R square value varies depending on the data set. So it is relative to the data we are using. Okay, so print R squared value. So you can generally say that if it is greater than 0.75, if it is 0.85 or 0.90, then the model is performing well. But it is not always the case. In some cases, high R value can also mean that the model is overperforming. So we don't want that kind of thing. So I will be explaining you in detail about how this R squared function works and how we evaluate our model, other kind of things in model training module. Okay, so I'll be making a separate module on those topics. But in this, just try to understand that this r squared value, goodness of this value can change depending on the data set. So it is relative to the data set, and we cannot give a general generalization that if it is more if the r squared value is more, then the regressor is performing well, or if the r squared value is less, it is not performing. So we cannot generalize it. So it varies relative to the data set. So that is one main thing. Okay, so now let's try to print this r2 train. Okay, so we get a r squared value of 0.63, which is actually kind of good. Okay, so in this particular case, and now we need to do the same thing, but in this case we need to predict for testing data. Okay, so we have already predicted for training data. Now let's predict for test data. So we just need to change few things. So this is for testing data, test data prediction. So the importance of test data is our model already, seen this training data. So it is trained on this training data. So evaluating on training data alone is not, necessary. So we need to evaluate it on based on the testing data as well, because our model didn't see the testing data. Okay. So now I'm going to predict the y value for this test data. And again, I'll find the r squared value. So the r squared value should be almost close to each other for R2 train and R2 test. So if that value is very different, then that means our model is overtrained. Okay. So R2 test, here we need to change this to Y test. So if you can see here, Y test is the corresponding Y value for this X test. So this is the original values, and this test data prediction is the one predicted by our model. Okay. Now let's again print this. So R2 test. Okay. So let's run this. So we get a value of about 0.58. So this is how you can evaluate our model. Okay, so these two are close to each other. So this is about Big Mart sales prediction. So I'll just give you a quick recap of what we have done. So the first step is to import all the dependencies. Then we have loaded a CSV file to a pandas data frame using this read CSV function, and then we have just printed the first 5 rows to see what are the different features. So I have explained you what is meant by all these columns, and then we have seen what are the missing values and what are the categorical features, and I've explained you how we can handle these missing values, and we have replaced this, numerical missing values by means of average, and with this mode by more repeated values. Okay. So and then we have found, we did some data analysis, we got some statistical measures, we found the distribution plot of some numerical values, and then we use the count plot to find the distribution of the categorical columns, right? So after the data analysis, we did some label encoding where we have transformed all the all the string data or text data into numerical values, and then we have splitted our data into features and target. Later we have splitted our data into training data and testing data, and we have trained our machine learning model, which is a XGBoost Regressor model, using this training data, and we have tested it based on this r squared value. Okay, so you can use some other regression models as well instead of XGBoost Regressor, and you can think of how you can, increase the performance of this model. Okay, so I cannot explain all those things in this video. So in some other modules I will be making videos on how to increase the performance or efficiency of the model and how to make better predictions. Okay, so but that is a topic for a different day. So I hope you have understood all the things we have covered in this video. So I'll see you in the next video. Bye.